All right, this is Mr. Gillum, and today we're going to talk about the mean absolute deviation. So fancy way, we're going to abbreviate that MAD, the mean absolute deviation. Okay, it stands for mean absolute deviation, and it's the average distance between each data value and the mean. So it sounds really complicated. Basically, what we're going to do is we're going to find the mean of the data. We're going to see how far off each data point was from the mean. And we're going to find that average, and it'll tell us how consistently we do something. So, as I was just explaining, we're going to find the average. Now this is the tricky part here. It seems confusing. Calculate the absolute value. What that means is we just need to know how far away each data is from the actual mean. And then we're going to find the average of those distances. So it's going to make much more sense once we do an example here, but this would be good reference in your notes here, these 3 steps. Okay. Well, let's take a look. Student A has test scores 85, 89, 82, 78, and 89. Student B has these test scores. Find the mean absolute deviation for each student and determine who is the more consistent test taker. Okay, so the MAD is going to tell us who's more consistent. The bigger MAD gets bigger, less consistent. MAD is smaller, more consistent. Okay, so first things first, let's find the mean of student A, and remember the mean is the sum of these numbers divided by how many numbers there are. So the sum of 85 plus 89 plus 82 plus 78 plus 89, all divided by 1, 2, 3, 4, 5. That's going to be the mean. So I'm going to find the mean of that one. I'm going to do the same thing here as well. I'm going to pause the video to do that calculation. And again, it's 1, 2, 3, 4, 5. 70 plus 85 plus 72 plus 95 plus 83. Let's find the mean of both those students first, and then we'll go from there. So the mean of student A is 84.6, and the mean of student B is 81. Now, it doesn't ask us who has the better test scores, because that would be student A. It asks us who's more consistent, and so to determine who's more consistent, we need to find the MAD, the MAD, the mean absolute deviation. And so what I need to do is I'm going to take every data point for student A. Okay, 85. I'm going to write it a certain way, and I hope you write it the same way on your notes. 89, 82, 78, and 89. And student B, their test scores were 70, 85, 72, 95, and 83. All right, to find the mean absolute deviation, I need to know how far away 85 was from 84.6. So what I'm going to do is I'm going to subtract 84.6. And I'm going to subtract 84.6. I'm always subtracting the mean. Minus 84.6. Minus 84.6. Minus 84.6. And on student B, I'm not subtracting 84.6. I'm subtracting 81. And what these 2 lines that I wrote here, those are absolute value bars. What we're finding is not the difference, but we're finding how far away the number is from the mean. So 85 minus 84.6 is 0.4. As a distance, that is 0.4. It's 0.4 away. 89 minus 84.6 is 4.4. And that as a distance would be 4.4. 82 minus 84.6 will be negative 2.6, but that's not a distance because negative numbers can't be a distance. We can't get smaller than a distance of 0. That's why we're taking its absolute value. Its distance would be 2.6 away. 78 minus 84.6, negative 6.6, but we're going to take its absolute value, 6.6. That's how far away 78 is from 84.6. And then 89 minus 84.6. is 4.4. So again, 4.4. All right, I'm going to do the same thing here on the next on student B, but I'm going to go ahead and pause the video because I don't want this to go too long. Take a second to record these values, and it's just the same thing that I did with student A. We're taking the absolute value of the difference of those numbers because we want to know how far away they were from the actual mean. And we're not there yet. Now is the calculation of the MAD, the MAD. I know the MAD is the average of these numbers. So I'm going to find the MAD by taking 0.4 plus 4.4 plus 2.6 plus 6.6 plus 4.4. I'm going to divide all of that by 1, 2, 3, 4, 5. 5. I'm going to do the same thing with student B. I'm going to find the MAD, the mean absolute deviation, and that is 11 plus 4 plus 9 plus 14 plus 2, all divided by 5. We're just finding the mean of each of those. Okay, now whatever mean absolute deviation is smaller, that's the more consistent test taker. So I'm going to pause the video again and do that calculation. Calculated the average of the difference of the scores from the mean. I found that student A had a mean absolute deviation of 3.68. Student B had a mean absolute deviation of 8. So that means that student A was closer to his average every single test that he took than student B was. Student B was an average of 8 away from his total average, and student A was only about 4 away from his actual average for every test that he took. So in this case, when it says who's more consistent, the smaller it gets, the more consistent. So we're going to have to say student A is more consistent. Okay, so kind of a long process for the mean absolute deviation. Example 2 says the table shows the points scored by Lucas and Peyton during the last 5 basketball home games. Calculate the mean absolute deviation for each boy's points and then answer the questions. Who scored the most points? Okay, well we can do that one pretty easily. Whoever scored the most points, we're just going to add up how many Lucas scored. 4, 8, 13, 17, 22. Lucas scored 22. Peyton scored 19, 21, 22, 23, 24, 25. So Peyton scored the most. Which boy had the greater average? Okay, well the next thing we have to do is we'll have to add those up, and we decided that was 22, and we're going to take, for L, we're going to take 22 divided by 1, 2, 3, 4, 5, 5. And for Peyton, we're going to take 25 divided by 5. So 4.4 and 5. So who had a bigger average? Peyton did. It says based on the mean absolute deviation, which boy do you think is a better player on any given day? Ooh, so we're looking for the more consistent player. So I know this average is 4.4 for Lucas. I'm going to take 4 minus 4.4. Its first data value minus 4.4, his second, his third, his fourth, and his fifth data values. So 4 minus 4.4, 5 minus 4.4, 4 minus 4.4, and 5 minus 4.4. I'm going to take the absolute value of that because I'm looking for the distance away each time. So it looks like negative 0.4, which would equal 0.4. Negative 0.4 again, which would equal 0.4. 0.6 this time, 0.6. Negative 0.4. And 0.6. Now I need to find the average of those. So I'm going to add all of them up and divide by 5. So 0.4 plus 0.4 plus 0.6 plus 0.4 plus 0.6. 2.4 divided by 5 equals 0.48. So that's what we're looking at for Lucas. All right, so take a second to write those down, and I'm going to erase that, and I'm going to make Peyton's chart here. Okay, oops, I'm going to write down Lucas. Lucas, we decided, was 0.48 for his mean absolute deviation. Peyton scored 19, 2, 1, 2, and 1. And his actual average was 5. So I'm going to subtract 5 from each of those numbers. Take the absolute value of that. which represents the distance that we're going. And I see we got 14, 3, 4, 3, and 4. I'm going to add those together and divide by 5. Looks like his MAD is 5.6. So if Lucas's is 0.48 and Peyton's is 5.6, Lucas is hands down the more consistent player. So we're going to go with, based on the MAD, who's most consistent, who's the better player. Lucas is the better player on any given day. All right. Looks like we got another example here, and these are taking a long time to do, so this might be our last one. It says Lisa and Beverly scored the grades shown below in their last report card. Which girl had the overall higher average, and what conclusions can you draw from the table below? Use mathematics to justify your answer. Okay, so what we're going to do first is we're just find the mean of each of these girls, and to do that I'm going to add up the scores for Elisa and divide by 4 this time, and I'm going to do the same for Beverly and find her average. Divided by 4. Their average or their mean. I'm going to go ahead and pause it, and I'm going to do that calculation. So it looks to me, after I found the average of Elisa to be 86 and the average of Beverly to be 84. So it tells me the higher average would be Elisa. Higher average. Now let's decide who's more consistent. Is it A or B? Okay. Elisa or Beverly. So to find Elisa's, we know her average was 86. I know 93 minus 86 is 7. 62 minus 86 would be negative 24. And 95 minus 86 would be 9. 94 minus 86 would be 8. So 7, 24, 9, and 8. I need to find the average of those, so I'm going to add them up and divide by 4. 48 divided by 4 equals 12. So this is for Elisa. She has a mean absolute deviation of 12. For Beverly, we're thinking, okay, 84 minus 85 is negative 1. 84 minus 82 is 2. 84 minus 84 is 0. And 84 minus 85 is negative 1. So her mean absolute deviation looks like it's going to be much smaller, so she's probably going to be more consistent. 1 plus 2 is 3, plus 0 plus 1 is 4. We're going to divide that by 4. 4 divided by 4 is 1. So her mean absolute deviation is only 1. She is much more consistent. Beverly is much more consistent. Their MADs are 12 and 1. That means that Beverly on average is only 1 away from her total average, but Elisa either gets really high scores or really low scores. They're 12 away from her actual average. All right. So that leaves one more example here. Let's just read through it real quick. It says Jonathan and Sarah earned the following scores in their last 5 tests using a sound mathematical explanation. Who's the most consistent? So what I want you to do is I want you to figure this one out. I need you to find the MAD for Jonathan and the MAD for Sarah. And then we will talk about this one when you get back to class. So that's it for today.